In this video, we will discuss static variables and methods in Java. Before discussing static variables, let's review instance data variables. Instance data variables describe attributes or characteristics associated with individual objects. These variables are declared inside of the class, but outside of any method. These variables can be used anywhere in the class. Each object has its own version of the instance data variables. The instance data variables last as long as the object lasts. For example, let's say you had a customer class. It might have instance data variables for name, ID, and a list of order numbers for every order that the customer has made. Every customer object will have its own name, its own ID, and its own list of order numbers. Every instance or object you create will have its own version of these instance variables. Static variables are different. Static variables, also sometimes called class variables, are associated with the class itself, not with any single object or instance of the class. There's only one copy or one version of a static variable, and it's shared by all instances of the class. For example, in our customer class, you might keep track of the total number of orders across all customers. This would be a static variable because it's shared information. It's data that's stored only once and is shared across all customer instances. You can see that we've declared the variable using the static keyword. You might also have a count of all customers that have been created. This is one piece of shared data that really describes the class itself rather than any individual customer object. And again, we've declared it as static. You might also keep track of the most recent order made, no matter which customer made it. That would also be static because it is, again, a shared piece of data that's associated with the customer class in general, not with any individual object. Static variables are still variables, so they should be declared as private. They should also follow naming conventions for variables. They should be descriptive and use lower camel casing without underscores. When would you want to use a static variable? Make a variable static if it represents shared data that is the same and/or shared across all objects. Also make a variable static if it's really more of a characteristic of the class itself, rather than any individual object or instance. Common examples of data that should be stored in a static variable are a count of objects, or a total, average, or other summary of some value across all objects. Let's quickly review the basics about instance methods. Instance methods are meant to represent behavior or functionality that an object takes. Instance methods often change the attributes or characteristics of the object. For example, we might have a method called place an order that would add an order number to the customer's list. When we invoke an instance method such as this, we use an invoking object. In this example, we've created a customer object called customer A. We invoke the place an order method on that object. We're asking that specific object, customer A, to take that action, place an order. And in many cases, including this one, the object is changed as a result of invoking the instance method. Static methods are different. Just like a static variable is associated with the class instead of one single object, a static method is also associated with the class, not with any object. In our customer example, we might have a static getter method that allows us to access the total count, the total number of customers, or the most recent order. All of these are static methods because they represent functionality related to the class itself and to the static variables. You can see that each method header includes the static keyword. It's best practice to use the name of the class when referring to static variables. This isn't always required by the compiler, but it's good practice because it's a visual cue to someone reading your code that this is a static variable. You can see that in these static methods, we reference the static variables using the name of the class, even though we're inside of the customer class. Another example of a kind of static method is one that is more like a functional or a helper method. You might have, for example, a method that takes in a customer object and a list of priority or VIP customers and determines if the customer is a VIP based on whether the customer appears on the list. This is an example of a method that might be static. It's like a utility or a helper function for the class. Similar to when we access static variables, it's best practice to invoke static methods through the name of the class. This isn't always required by the compiler, but again, it's a good cue to your reader that the method is static. In this example, we invoke the isVIPCustomer method through the name of the customer class. Inside of a class, static methods can access static variables. Inside of a class and inside of a static method, you can access static variables, but you cannot access instance data variables. Instance methods can access both static and instance variables. And again, if you're inside an instance method, it's best practice to use the name of the class when accessing that static variable, because it makes it more clear for a reader. Remember, you cannot access instance data variables from inside of a static method. That's because a static method is associated with the whole class, not with any one object or instance, so a static method wouldn't know which object's instance data variables to use. Here's an example of when a static variable might be updated in an instance method. Let's look again at our place an order method. When an individual customer places an order, we want to add that order to the customer's list, meaning we update the customer's instance data. That's what we saw in this method previously. But now that we have our static variables, we also need to update those static variables that represent the order count and the most recent order. Similarly, in the constructor, when a new customer is created, we want to update the total customer count. So when would you want to make a method static? Consider making a method static if it's more of a utility method or helper function. Consider a static method if the behavior represents behavior of the class itself rather than a single object. Finally, make a method static if you're using it to access or modify static variables, like a getter or setter for static variables. If a method represents behavior or functionality that an object will take, do not make it static. If a method needs to access or change instance data variables, you most likely do not want to make it static. One more note about a common use of the keyword static. It's best practice to declare constants as static. Because the value of a constant cannot be changed, and all instances will share the same value, it's not necessary to store multiple copies of that same value, so it's best to declare constants as static. This has been an overview of static variables and methods. The key thing to remember is that static means associated with the class, not with any individual object. Happy coding, Java monsters!